All right, today we're going to talk about one of the applications of geometric sequences, and that is compound interest. This is lesson 3.4 in the unit, so let's get started. Normally, interest is compounded yearly. That means every single year, but not more frequently than that. So if I have $500 and I want to invest it for 3 years at 6% per annum, that just means per year, then after 1 year, it's going to be worth the $500 that it was worth before, plus 6% more than that. So remember, in our last one of our previous lessons, we talked about that being the same as 106% of what was there before. So I'm going to take the $500 and multiply it by 106%. Then after the second year, I multiply it by 106% again. And after the third year, it's multiplied by 106% one final time. Okay, and that's about $595.51. Okay, so you kind of see a pattern, hopefully. Let's talk about the exact same situation, but talk more generally than specifically. So I have an amount P, which is a variable now. It's invested for T years at rate R. And that's a decimal, it's not as a percent, per annum. Then after 1 year, it's worth A, which is going to be the final amount. That's going to be P times 1 plus the interest rate, because remember 100% of it is already there. After 2 years, I multiply by 1 plus R again. And after 3 years, it's multiplied by 1 plus R one final time. So hopefully you see the pattern as well, now that we're even using variables, making it a little bit more difficult. So after T years, what you notice is the only thing that changed was the exponent of 1 plus R, and that simply reflected the number of years that it was invested. So in general, after T years, it's worth P times 1 plus R raised to the T. Okay, so that's the amount that it's worth. Now what if it's being compounded for amounts or for intervals that are not yearly, so more frequently than that? So if an amount is invested at 12% per year, you can compound it twice a year at 6% each time, 4 times a year at 3%, 6 times a year at 2%, or monthly 12 times a year at 1%. So there is a difference in the amount that you will get, because the more frequently you compound, the more money you will have, the more interest you will have earned. Okay, so in general, if I want to compound K times a year, then I take the original investment or the original interest rate and divide that by the number of times I am compounding per year. Okay? So in general, also the interest rate, instead of being 12%, it can be whatever rate you want. So the interest rate is going to be R over K. And the number of periods, since we're investing it over T years, but we are compounding it K times per year, then the number of times I compound that money or that interest is K times T. Okay, so let's talk about that. The general formula then is going to be P times 1 plus R over K, because that's the new interest rate, because it's being divided depending on how many times you're compounding per year. And the exponent changes as well, because we are multiplying by that factor more times as we compound more throughout the year. So the exponent becomes KT instead of just T. All right, so if I wanted to invest $500 at 6% compounded quarterly for 7 years, that means my interest rate is 0.06. K is 4, because that's how often it gets compounded per year, and T is 7. It's still 7 years. So I plug everything in, and I get that my money will be worth $758.61. Okay, another way you can look at these, instead of investing money now and seeing how much you have in the future, you can plan for the future by saying, I will need this certain amount of money in this period of time. So how much should I invest right now? That's the second kind of question we deal with. So if I want to have $8,000 in 10 years, how much should I invest into an account that has an interest rate of 9% compounded monthly? All right, so same formula. I have everything I need. The $8,000 is what I'm hoping to end up with. So that's my A, that's not my P. That's not the amount I originally invest. In fact, I don't know that, so I'm solving for P this time. My interest rate is 9%, 0.09. K is 12 because I am compounding this 12 times per year, and T is 10 because I'm investing for 10 years. So plugging everything into the formula, I get that 8,000 equals, and I simplified what I could on the right and got 2.45136. That's probably rounded, so make sure you keep the complete decimal in your calculator if you're using a calculator. So all I need to do is divide the 8,000 by that 2.45136, and I will have solved for P. That gets me $3,263.50. That's how much I need to invest right now if I want to have $8,000 in 10 years. If that's the interest rate, if it's compounded monthly. So all of those factors come into play. So that is compound interest. If you have any questions, let me know, and I will see you tomorrow.